All right, so today we're going to learn about metric and scientific notation. And these are two topics I imagine you guys are familiar with. You probably have done this before, but it's really, really important to cover both these topics. So metric system. I think, again, being in the United States, metric is a little bit more confusing or challenging for you guys. Um, for the rest of the world, metric is the adopted system used in everyday life. So students are used to working with kilograms or kilometers or meters or liters, where we don't really come in close contact with these items outside of science and engineering fields. So the reason why metric is important is it's universally utilized in science. It doesn't matter what laboratory you're in the world, metric system is the accepted usable standard for everything. It's also incredibly easy to convert. All you do is you move a decimal place one direction or another, and that makes it happen. A good way to learn the metric system, because I know a lot of students still struggle when it comes to where do you move the decimal point in metric. And this is a real silly thing I used to teach when I taught middle school, but it's highly valuable and informative, which is kiss her dog, but don't call me. And that kiss her dog, don't call me stands for all the prefixes in metric. And the big ones we'll utilize will be obviously kilo, the meter, liter, gram, deci, centi, and milli are the big ones for this course. And so a big deal is, okay, well, now you have this kiss her dog, but don't call me. Like, how is that useful or helpful? And what I like about this is that you struggle with this. If you write this down, it'll tell you which direction and how many decimal places to move stuff. So we're going here from 15 kilometers, which is kiss, to meters, which is in this butt. And kiss to butt, it's moving 3 boxes or 3 places and 3 places to the right. So you have to then move the decimal point from right here behind the 15, and it's going to be moved 3 places to the right to now become 15,000 meters. The same thing happens in reverse. As we start off with 560 milliliters. Milliliters is over here in milli. We're going to liters, which is again at this butt, which is meter, liter, and gram. You're moving 1, 2, 3 places and 3 places to the left. So the decimal point will be moved from the 0, 1, 2, and 3, and you should get 0.560 liters. So I know many of you can convert metric really, really well. For those of you that still struggle, this is a good crutch or tool to always help you adjust when it comes to metric conversions. So let's do a bigger one. So we have kilogram to milligram, and we have 1.2 kilogram to milligram. Kilo here is in kiss. Milli here is in me. So it's 1, 2, 3, 4, 5, and 6. And 6 places to the right. When you move 6 places to the right, you're going to end up with 1,200,000 milligrams. Now what I'd like you guys to do is pause the video at this point and work out these 4, and then you can restart it to see the answers. If you have any questions over this, please bring it up in class, and I'll be more than happy to discuss it. All right, so here are the answers. Meters to centimeters, you should move 2 places. So it's going to be 18,000. Milligrams to grams is going to be 3 places to the left, so 0.150 grams. 15 kilometers to millimeter will be 15,000 millimeters. And 35 milligrams to grams is going to be 0.035 grams. Next topic with this is scientific notation. So a question I always get, why do scientists use scientific notation? And the answer is pretty straightforward. Unlike in everyday life, science works with incredibly large and incredibly small numbers. So you have to have some system to make it easy to discuss these incredibly large and small numbers that you will end up working with in science. And given we're studying chemistry, we're looking at atoms and molecules and these small chemicals, it's going to be crucial to be able to talk about these without going insane from just the large numbers that we'll be discussing. So how does this work? The goal is to move the decimal to attain a number between 1 and 9. If you move the decimal to the right, you're going to have a negative exponent. If you move the decimal to the left, you're going to have a positive exponent. So on these two examples here, on example A, my decimal point is here. I want to get a number between 1 and 9. So I'm going to need to move the decimal point from here to between the 1 and the 5. If I move it here, it's not 1. If I move it here, it's above 9. So the only logical place to move the decimal point is here, and then I just count and put the exponent. So I moved it 1, 2, 3, 4, 5 places. I moved it to the right, so therefore it's going to have a negative exponent. So it'll actually be 1.5 times 10 to the negative fifth. For 2 million, again, I need to get a number between 1 and 9. I'm going to move the decimal point to the 2. It's going to move 6 places to the left, so it's going to be 2 times 10 to the power of 6, which you can see right here. I put in red the exponents and what they're supposed to be. So here's some practice. Go ahead and pause the video at this point. Go and try these 4 problems, and then I'll have the answers on the next slide. All right, here's our practice. So 98, you're going to move it 1 place. It's going to be times 10 to the negative 1. I'll never ask you guys to put a number this small into scientific, but I think it's a good one to kind of practice with to start. For B, you'll end up with 8.765 times 10 to the negative third, because you're going to move it 3 places to the right. For this one, we're going to standard form, so you have to know how to adjust from that. If it's times 10 to the fifth, you'll move the decimal point to the right. And if you're going to standard form, then you have to move this decimal place to the left. So it's opposite of what you did to get scientific. I do have an assignment for you guys to do over metric and scientific. That's on Canvas. You will go ahead and work those problems out and then submit them into Canvas for me to grade. And there will also be, this will definitely be on a future quiz or a future test. So if you have any questions, let me know. If not, that's all I have for today. Awesome. Good job.